Okay, so this time we're going to talk about the Vigenère. And sorry, it's going to like keep drawing here. I have to clear and make sure I stop it. Okay, so Vigenère Cipher, before starting, is quite the fun cipher. And it was like for quite a long time, for centuries, it was called Unbreakable Cipher. And in actually is named after the 16th century French diplomat, and that's Blaise de Vigenère. But it was invented earlier, and in 1553 by an Italian cryptographer called Giovan Battista Bellasso. And Vigenère created a similar but more complex variant, and but the polyalphabetic system that we call Vigenère today was Belasso's works. And the cipher gained in reputation because it was a polyalphabetic. I mean, it was a different series of Caesar ciphers, and I'll show you why that's the case here. And this made it immune actually to simple frequency analysis that is possible for Caesar cipher or ROD 13 that I explained in the previous video. And it was broken by the father of the computer, as you can guess, Charles Babbage, in 1854, but he didn't publish the work actually that time. And later, the method for cracking it was published and known as Kasiski examination. Because it was independently published in 1863 by a cryptanalyst that was called Friedrich Kasiski. Okay, that's all for the theory. Now, I mean, the story behind the cipher. Now I'm going to show you how this uh, cipher works. So this is the table that we have. It's quite simple. I just have to make sure that I have enough room here. Okay, perfect. So what I do here, I look at the first column here and I say this is my key, and the rest are actually the first row here. This is going to be my plain text. So this is my plain text. Let's say Alice wants to send a message to Bob, and the message is, so I write here, message or plain text. Of course, those are the same thing. Message is hello, and key is, let's say, key, for example. So key is equal to key. But you can see that the key should be the same size of the message. So for solving this problem, I repeat this key until I make sure that message and key are the same size. So it's going to be key E. Perfect. Now I can get my ciphertext. Ciphertext. And so for the first letter, I know that the key is K and the message is H. So the message is H. I have to find it here. Yeah. Here. And if I find the intersection between these two, I get to letter R here. So this is R. Now for the second letter, both the key and message letters are E. So I choose E here for the key and also another E for the plain text. Now find the intersection of these two. And it's going to be I. If I'm not wrong, yes. I. Now key is Y. Sorry, I just checking. Key is Y. And message is L. So message is L. So I have to find the intersection of these two again. I continue here. And here also I continue. And you can see that I got to letter J. Now key is K. Again, I had K. Let me just change the color. This is K. And the message is L. So we had L before. So we continue until I find the intersection of these two. That's actually V. Sorry, it's a bit messed up there, but I hope you see that. So that's going to be V. And finally, O and E. O and E on the, I know that the key is E. So let me change the color again. Key is E and message is O. So I continue here and message is O. Intersection of these two give me S. Let me just make sure that it's all the same color. So my ciphertext now is RIJVS. Now, if Bob wants to decrypt this message, it's pretty straightforward. We have RIJVS, and we are trying to decrypt it. Let me clear my drawing here because this is not really good. I have to actually clear everything. That's okay because I know my ciphertext so far is RIJVS. Okay, ciphertext. Ciphertext is RIJVS, and I know that the key is equals to key. Now I have to do the operation, quite similar operation on ciphertext and key to get the message. Okay, so now you know that the ciphertext is the content of the table. And again, just to make sure that we are clear, this is the key and this is the message. And the content of this table are ciphertext. So now let's start to do this by green color. My key is K. So where's K is here. And my ciphertext is R here. I find the intersection of these two. I don't cross this time because it's not to make a messed up. And it should, sorry, not R here. I made a mistake here. I apologize. I know that the key is here K and ciphertext is R. As I explained, I should look for R inside the table. So I continue looking in the same row and I find R. And now I find the plain text. So it corresponds to H. Now for E and I. So I know that my key this time is E. And my ciphertext is I. So I continue here and I find I. And I see that this will map to E. Now next is going to be Y and J. Key is Y. And ciphertext is J. So I continue here and I get to J. And I find the mapping on the first row. So I continue this, continue, and I get again to L. Next, K and V. K is the key. Again, K. Let me just change color. K. And I have to find V. Here's V. And then I map to the first row. And that's going to again give me L. And finally, E and S. Key is E. And I have to find S. That is here. And this gives me O. So yeah, surprise, surprise, we could recover the message. Now I'm going to show you the same concepts in the crypt tool that I showed before. Let me just clear my drawings. I show you better. Okay, so let me see. Here we are. So I'm going to do the same. Sorry, it's going to be a quick demonstration here. I just have to make sure that, okay, that's fine. So here my plain text is hello. And my key is key. And let's run this with Vigenère. If you make sure that all the letters are either uppercase or lowercase, you see things better. Let me see key and here all uppercase. So you see, I chose all of them uppercase now. Hello and key, and it gives me RIJVS, exactly as we calculated before. And of course, if you had a ciphertext like this, let me remove here. Let's say Bob received the ciphertext and paste it here, and we get hello back. Yeah, very nice. So that's the end for Vigenère Cipher. Okay.